All right, some of the goals for this project is that we want to have the user be able to completely control the model car using gestures or buttons. They will be able to switch between modes using the slider switch. The system should be able to easily recognize and accurately recognize each single motion. So if I designate this as right and the user does that, should detect it 100% of the time for it to be actually accurate. If it's not, then it will be unsuccessful. We'll also want to have 5 gestures controlling 5 distinct motions. These will be designated forward, backwards, right, left, and then our 5th motion will be a donut. And if it meets all those specifications, then it will be done. All right.
So I'll briefly explain the components we used in our project. We had several buttons. 4 of them would be used for directional control, and one of them is used for gesture capture. So a slider switch is used to switch between manual mode and gesture mode. And in manual mode, the gesture mode buttons and information collection and execution don't work. But when we switch to gesture mode, an LED turns on every time we press the gesture capture button, and a motion is predicted based on a gesture that is done, uh, and the car moves based on that motion.
All right, some of the goals for this project is that we want to have the user be able to completely control the model car using gestures or buttons. They will be able to switch between modes using the slider switch. The system should be able to easily recognize and accurately recognize each single motion. So if I designate this as right and the user does that, should detect it 100% of the time for it to be actually accurate. If it's not, then it will be unsuccessful. We'll also want to have 5 gestures controlling 5 distinct motions. These will be designated forward, backwards, right, left, and then our 5th motion will be a donut. And if it meets all those specifications, then it will be done. All right.
So now I'll go ahead and briefly describe the process of collecting data and training the ML or training the model to predict what gesture is being made based on the actual gesture that is being made. So initially, how it works is we use an SD card and we hook it up to the remote with the MPU sensor, and we would just move the remote around, and we would repeat each gesture a minimum of 100 times. For our project, we did it 120 times to improve the accuracy of the model. And after collecting that data, we would process that data set. So we had 5 gestures: back, left, forward, right, and donut. And donut, it would just spin in the circle. And how it would work is we would go into the data collection algorithm in the Arduino environment, and we would rename uh, the motion that we are currently working on, and we'd press the button just like in the demos that we're going to show. And after pressing the button, an LED turns on for about a second, and we're supposed to do the motion. So we would do each motion, as previously mentioned, about 120 times, and it would collect 100 data samples per second. So each motion has 100 data samples. Then we would process that. So we would take the Excel files, convert it to CSV, comma separated value files, and organize in such a way they'll be understood by the Python algorithm that is used to train the machine learning model. So the data set is used to train the model. Machine learning is used to do that, and it outputs a confusion matrix which shows how accurately the model has predicted which gesture is what. So after doing that, the Python script outputs a hexadecimal, has like a huge hexadecimal output, which you then copy and paste into the header file for the gesture prediction. So it uses that data, it uses the trained model to predict the gestures based on the gesture actually being made. So after that, we can use the remote, and the gesture that's made on the remote is then that gesture is then predicted on the model, and that model predicts whether the gesture is saying to move forward, backward, left, or right based on what we have assigned it to do. And that's essentially how the model training worked.
All right, so now that Sid has explained the data collection and machine learning, I'll go into how we communicate from our gestures and buttons to our actual RCM car. So here we have the car, we have our motor driver right here, and we have two motors right here, and we have the ESP right here. So when we send something from the remote, either through the buttons or through a gesture like this, we will send like a 1, a 2, a 3, or 4, or 5, representing each motion. And then once that is done, we send it to the other ESP32 using Bluetooth protocols. Once the ESP has received that, it will turn on each one of the motors. So if we wanted to say, let's say we want to move forward, we move A1 and B1 high and B2 and A2 low. If we wanted to move right, we just move A1 high, B2 low, B1 low, A2 low. If we wanted to move backwards, A2 high, A1 low, B2 high, B1 low. Stuff like that. That's how we control the movement of our car based on the gestures or the pushing of the button. And then those are PWM signals that are being sent to each motor, which is regulated by the motor driver right here. All right, so we have two modes to control the model car. We have the manual mode and the auto mode. Right now I'll be going over the manual mode, which you can control using 4 buttons, one for each direction. So for example, this will make it go forward. We could stop it with another press. This will make it go backwards. This can make it go right. One motor is moving more than other, which is making it turn. We can't really see that right now. And then if we use this, we have opposite, like this motor is moving more, so it's moving left. So yeah, that's basically how it works for the manual mode. Now Sid will be going over the gesture mode.
Displaying gesture mode and how it works. So when we press this button, this LED will come on, showing and indicating that the gesture is ready to be captured. So I'll press this, LED comes on, and the car starts moving. And right now it's detected gesture 0 corresponds to both gestures are currently. And if I were to do something like this, it would detect gesture 1, and now both wheels are moving backward. If I were to do this, it would detect gesture 2, which means now it's going right, and one motor is moving faster than the other. And for gesture 4, it looks something like that. Very subtle motion, and only one wheel moves here, performing a donut.
Gesture 5, actually.
Oh yeah, sorry, gesture 5. Alright, let's try making go forwards. I'm going to make it stop going forwards. Now I'll try making it do a donut.
It's stuck.
So here we have Jack controlling the car remotely.
So now we're going to go forward, or backwards, sorry. Then we're going to go forward. Then we're going to turn right. We're going to go forward again, left, backwards, and then let's do forward again. And now we're going to try to switch to gesture mode. So we're going to turn the switch. We're going to press this, and let's say forward, right. Let's try another one. Let's go backwards. Let's go backwards.